All right, let's talk about a few more examples of applications of factoring, section 5.8. If you look at example number 2 with me, it says Terry and Jody registered their boats in the Lakeport race at the same time. The racing numbers assigned to their boats were consecutive numbers, meaning numbers in a row next to each other. The product of which was 156. Hopefully you know that product in math means to multiply. We want to find their two racing numbers, right? Okay, so let's read that carefully again. The racing numbers assigned to their boats were consecutive numbers. So if I got 7, then the next person got 8, right? The product of those two numbers is 156. So let's start translating this into mathematical notation. Now, don't make fun of my drawings, but I'm imagining two boats. I have the first boat that was assigned a number. I'm not sure what that number is, so I'm going to call that X. And I do know that the next number was the next number in line, consecutive number. So it's one more than the first one. If the first one was 8, the next one would be 9. If the first one was 27, the next one would be 28, and so on. So if the first one is X, then the next one, the consecutive number, would be X plus 1. I don't want to call it Y or a different variable because I don't want to have too many variables in my equation. All right, here we go. It also says in my problem that the product of these two numbers, whatever they are, is equal to 156. So now I'm going to use that to make an equation. I know I have the first boat, which is X. I know I have the second boat, which is X plus 1. And I know that when I multiply them together, the product should be 156. So now I have an equation that looks like this. All right, this problem isn't just asking us to set up. We actually have to find the two numbers. So we've got to solve for X. What I'm going to do is I'm going to distribute this X, I'm going to distribute this X through to my parentheses here. I'm also going to move the 156 over by subtracting so that everybody can be over to the same side. After I distributed the X and moved the 156 over and put everything in order to the same side, I ended up with a quadratic, a trinomial of x squared plus x minus 156 equals 0. Now this looks like a problem that I can solve by factoring. I'm looking for a GCF. I'm looking to see how many terms there are. There are 3. And so then I know it's either a basic factor or a bottoms up. So in this example, this would be a basic factor problem. Numbers that multiply to negative 156 that add to 1, you might need to try a few. I had to take my calculator out and try a few numbers, but I eventually ended up getting x plus 13 and x minus 12. Now that still isn't finished though. We still need to figure out what x equals, and we don't quite have that yet. All we have is the two factors set equal to 0. But now I can set them each equal to 0 and get x equals negative 13 and x equals 12. Okay, so now that we have answers, let's figure out what those answers really mean in the scenario. So remember that x really represented the number of each boat. And when we go down and look at our answers, it probably doesn't make sense for the boat numbers to be labeled as negative numbers, right? So negative 13 probably doesn't make sense in context to this problem. But 12 could make sense. Maybe when Terry registered, he got the boat number 12. Now, if Terry got the boat number 12, then what was Jody's boat number? Remember, weren't they consecutive numbers? So if I take x plus 1, then that means that Jody has the number 13. So I can label my answer, and I can say that Terry's number was 13, and Terry's number was 12, and Jody's number was 13. So I can make sure that I label my answers so I know that you understand what those numbers actually mean. All right, let's do one more in this video. Example number 3 says wooden work builds cutting boards, right, where you cut, food on. They are twice as long as they are wide. The most popular board that wooden work makes has an area of 800 square centimeters. What are the dimensions of the board? So this question is asking us for the dimensions of the board, length and width. So I need to make sure that I have both of those answers in the end. I'm imagining a cutting board as a rectangle. I know that there's a length and a width for my rectangle. And it does tell me something about the area, the stuff inside, right? Now, do we know what the width is? No. Do we know what the length is? No. But it does say that it's twice as long as the width. So if the width is W, then the length would be twice that. So instead of calling it L, can I call it 2 times W? If my width is a certain amount, and I know that the length is twice that, well then I should be able to double it, multiply it by 2, and that would give me the length. So I have the width as W and the length really as 2W. That way I can stay with the same variable and not use L's and W's at the same time. Okay, what else did it say? It also said that the area, that's length times width, is 800. So let's start making that into an equation. I know that length times width is the area. Area is equal to length times width. I know that the area is 800. And I know that area is length times width. But again, I don't want to keep it with L's and W's. I want to try to write it with a single variable. Well, I know that the length, remember, is twice W, so 2 times W. So instead of writing it as L, I can write it as 2W. So now I have an equation that says 800 equals 2W times W. That's really the length times the width equals the area. I can simplify it a little bit. 2W times W is 2W squared. I can move the 800 over to move everybody to the same side, set equal to 0. I can look for a GCF. It looks like I can GCF out a 2. That leaves me with a W squared minus 400. The polynomial that I have left has 2 terms in it, so I'm going to try to factor with the difference of squares. So what is the square root of 400? You should end up getting positive 20 and negative 20 as your 2 conjugate binomials. Now that I have all of my factors, that's 1, 2, 3 factors set equal to 0, I can set each one equal to 0 and figure out what W equals. When I set the 2 equal to 0, I get an equation that doesn't quite work, so that's gone. I end up having a W equals negative 20 and a W equals 20. Okay, great. Answers are done. But what do they really mean? And this is really the most important part to me, is I want to know that after you get an answer, you actually know what it means in this scenario. So what did W represent in our problem? Well, W represented the width of our cutting board, right? And so does it make sense for the width of our cutting board to be negative 20 centimeters long? Not quite. So that's probably an extraneous solution, or a solution on this one that doesn't really work in context, okay? But it does make sense for my width to be 20 centimeters. Now, if my width is 20 centimeters, then what does that make my length? Remember, doesn't it say that the length is twice the width? So if the width is 20, well then that would mean that the length is really 40. We're going to label it appropriately. We're going to say that the width is 20 centimeters and the length is 40 centimeters. And it should make sense on our picture. It should also make sense if we double check and multiply those two together to calculate the area. We should end up getting 800 like it said it was supposed to be. So quick little double checks to make sure that our answers make sense and are correct. All right, those are 2 more examples, both different types of problems. You will have all different types of word problems, so it's really important that you practice, practice, practice. That's the only way that things are going to get easier, okay?